Now we are in 11th session of 11th Nepal Geological Congress. New session. New session. Because until now we were in geomorphology, stratigraphy, paleontology, and tectonic sessions since yesterday, whole day and today morning. And now we are in new session. That is mineralogy, petrology, geochemistry, and geochronology. I would like to invite Professor Royal Bollinger, chairperson of this session, and Professor Rainer Klein from Germany, I would like to request Professor Bollinger to start the session.
Thank you. Welcome everyone. Six interesting talks this afternoon, and we will begin with the keynote. So the keynote speaker will be Aaron Thomas, and he will talk about refining thermometry, assessing the accuracy and reliability of metamorphic PT estimates.
And especially I will discuss the refining thermometer, assessing the accuracy and reliability of metamorphic PT estimates. And reliability of metamorphic PT estimates. Importance of thermometers, if you will see, they are often difficult to get reliable PT estimates, and because it is a very tough. If you are not aware how to choose the pairs, those who are in domain equilibrium, we have to know how the data we can use, especially the EPMA data, for applicable in the thermometers or barometers. So often difficult to get reliable PT estimates, essential for understanding of metamorphic processes, because we have to keep in mind always what is the process, whether we are in prograde or retrograde metamorphism, how we can choose the pair for thermometers as well as for barometers. Generally conducive to forming mineral assemblages that occupy a small area in PT space, that must be in domain equilibrium, and always if you plot KD, then we can find out what is the domain equilibrium of mineral assemblages. Multiple point sequence to understand deformation and metamorphism. Challenges: lack of experimental calibration, sensitivity issues, and inaccurate thermodynamic data. If you will see the background of geothermobarometers, so since 1976 onwards, there are numerous empirical thermometers proposed, and even the few experimental thermometers is also available. We have to choose which one is better for your area. Key issue in thermometers: many thermometers depend on assumption about water pressure. Some systems are unreliable due to inadequate structure characterization, and error in pressure estimates can be large as 1 to 2 kilobars. As we are aware, if you see how the thermometers work, the thermometers is direct proportional to delta V and inversely proportional to temperature, inversely proportional to 1 by ln kV. That is the thumb rule for thermometers. Thermodynamic data and models. Importance of an accurate thermometric database is very essential. Like thermocol, if you know the thermocol software, so there is a very accurate and updated database is there. But if you will see back the traditional thermometers and barometers, which is always used, even if suppose you go for advancement with different softwares, even in that case also you have to give the data at what pressure and temperature you are going to plot a certain systematics related with metamorphism. Errors arise from combining inconsistent data sets, and self-consistent data sets are crucial for minimizing the errors. So always you have to be very, very careful which data you are using. Volume change in solid equilibria require volume correction for PT changes. And if you see the thermometer is based on ion exchange reaction. Ion exchange reaction means if garnet and biotite pair is there, so both Fe and Mg and members like your phlogopite, anite, and almandine and pyrope, the 4 different pairs react and form different pairs. And there is only exchange of your cations with respect to very less volume change. So that is one fundamental rules. Thermometer is based with very minimum volume change. So T is directly proportional to delta V and inversely proportional to 1 by ln kd. The incorrect volume assumption lead to the significant error in 1 to 2 kilobars pressure and 50 to 100 degrees centigrade in temperature. Standard methods for calculating volume changes is there. Selection of samples, if you see, there is a clear description of textural equilibrium among garnet and contact mineral in literature. If you see the pair like garnet biotite, garnet quadrate, garnet OPX, garnet CPX, OPX CPX, and other like garnet chlorite also with ilmenite effect in biotite. So many thermometers is there, and there is a detail in high quality electron microscope analysis for the minerals involved, at least SiO2, TiO2, Al2O3, MnO, MgO, CO, Na2O and K2, and their spectrometry of the analyzed minerals was confined. So always you have to, means whatever data you have to procure, then you have to calculate the cation for that data, and then on the basis of that you have to find out the XMG, XFE of different mineral pairs. Pore composition of the garnet and ring composition of the quadrate has been mostly used. If there is a growth joining in garnet, only the ring composition was used, and accordingly only the ring composition of the matrix quadrate has been used. What is the reason behind it? Why we are using the ring composition if there is a joining in garnet or joining in pyroxenes? The reason, because in nature we will never find any pure garnet like pure almandine or pure gracilorite or pyrope or any pair, all 6 members growths. If you analyze any garnet, always you will find for using different thermometers as well as for barometer also. So normally the people, they go for regular solution models and sub-regular solution models. I am not going to give explanation how the regular model. If you will see the profile section of garnet in your area, sometimes almandine is more in rim and pyrope will be more in. Data is used where elemental oxide total for the mineral analysis upward Green's species up to downlights. And if you see the 1959, Kurtz introduced the FEMG distribution, temperature relationships, and 60 to 70 experimental refinement, the calibration of Garnet biotite thermometers, and 80 to 2000s, multiple models developed, especially each improving precision and applicability. I have compared 21 models evaluated, including Parchuk and Leventiva 1983, Holland and Holdway and Lee 1977, and Thomson 1976, Ferry and Spear 1978. Among this, the Ferry and Spear is your experimental calibration, and Hoses and Spear 1982. I have collected, in fact, all my teams, my students, we have collected 611 samples, data from global literature, processed through Garnet biotite software, which is I have developed a long back, and evaluated using regression analysis between LNKD and 1/T temperature. And I have found that, like the graph, you can see the LNKD versus 1/T, Parchuk and Leventiva 1983, and Holdway and Lee 1970C. All these four graphs, and another one also, showing a very good regression analysis, which is close to 1, and that predict these thermometers are best among all 21 other thermometers proposed by different scientists. And with this, like Hoses and Spear also, and then the area I have collected data, especially from Rajasthan, Antarctica, Himalayan metamorphic sequence, and southern gavelites, and I have compared with all these data from with respect to all important thermometers, and all areas suggest yes, they are the best thermometers among all 21s in Garnet biotite pair. Like Thomson 1976, Hoses and Spear 1982, Holdway and Lee 1976, and Parchuk and Leventiva 1983, and Ferry and Spear 1978. So these 5 are the best thermometers. One can use all these 5 in their research paper or in thesis also. This paper we have already published in Himalayan Geology. And likewise, the Garnet quadrate geothermometers, 11 models so far is proposed, and we have collected 70 samples from all over the world, and data processed through Garnet quadrate softwares, and widespread occurrences of quadrate in epiphytic metamorphic rocks occur with various combination of quartz, muscovite, potash feldspar, chlorite, biotite, aluminosilicate, staurolite, and albendine. With increasing temperature, these may be broadly characterized as quadrate muscovite phases, quadrate potash feldspar phases, and quadrate potash feldspar albendine subphases, and that is nothing, that is almost touching to gammarite phases. That is the gammarite phases assemblages. And again, the same process, I have plotted all these data with respect to LNKD and 1/T, and found that Holdway and Lee 1977, Onovich and Polsky 1979, Parchuk et al. 1985, and Wells and Thomson 1976 are the best models in Garnet quadrate systematic also we can say. And similarly, this paper is also published in Journal of Nepal Geological Society, and a lot of citation is there, especially in tectonic physics also, the persons they are quoting. And then Garnet clinopyroxenes, postal is there, and recently we have processed all this data, The garnet clinovirusen pairs commonly found in upper amphibolite facies, granolites and niclocyte facies assemblages, as well as in garnet pedotites in igneous system. Data processed through garnet CPS softwares. 11 garnet clinovirusen thermometers formulated since 1972, and 89 sample data we have collected from the published global literatures and processed through softwares, and we have processed and found that Parchuk et al. 1985, Ravana in 2000, Powell's, Graham and Powell's, they are the best models for 100 garnet thermometers. And similarly, the Parchuk et al. 1985 and Graham and Powell 1984. So these are the best models. In fact, one can use for their purpose, for publication purpose, and all these software is available also to plot calculations. Especially, even one can use the single pyroxene thermometers also. These are the models are available, and 10 models of 2 pyroxene thermometers proposed since 19 from the global literatures we have collected. These is more suitable for applicable of thermometer calculation, and especially in granite facies rocks found at Rath et al. 1983 and Sen and Bhattacharya 1984, Harley in 1984, model especially, and this paper we have published in especially in Arabian Geoscience. Garnet biotech thermometers, solid solution corrections is required. Then granite facies, high temperature equilibria, importance of dehydration reactions. Evaluate potential error due to the compositional variations. Apply multiple thermometers for consistency. Always you have to. So you have to choose the thermometers and barometers as a traditional thermometers. Pseudo-section plotting also. So conclusion, thermometers, geothermometer is essentially, but
so we have room for one or two questions.
I have a question.
Just first thing. Just I have one small query. You have so these softwares are free downloadable or
free on request.
on
Free.
request?
Yeah.
Okay, that's just.
Very nice.
In one software, you are also co-author.
That's different.
Wrong back.
Very nice presentation. Thank you for your great talk. My small query is you have talked about more about the geothermometry part, but geobarometry part seems.
Geobarometer is again same long process.
Okay.
I have not put it here.
And
Only geothermometers, traditional geothermometers, like different pairs, garnet biotech, garnet quadrate, garnet CPX, garnet OPX, OPX CPX, I have considered here. And we are doing on refinement on garnet different barometers also.
Okay. Thank you. And one more. Can we apply fluid inclusion studies along with this technique or no?
Fluid inclusion is entirely different because that setup is entirely different, and micro geothermobarometers is always you can go with your fluid inclusion data. Especially that will be applicable in granite facies rock and in ore geology purpose. If fluid inclusion is there, you have to go with micro geothermobarometers.
Thank you.
Let's move to the next talk with a show that will present the tectonometamorphic evolution of the Gyeonggi Massif in the similar area in Korea.
Thank you for Yada Kodaya. He kindly invited me to attend and session chair too. So thank you very much. And today I'd like to introduce some of Korean geology. Probably you are not so much aware of the fantastic story involved in Korean geology. Particularly Seoul, when you visit Seoul, you may enjoy all the different geology. And here is an example of the Jurassic granitors in the northern part of Seoul metropolitan city. We call it Bukhan Mountain. Bukhan Mountain is a kind of national park, and you can reach there by subway or bus. Easy to climb up. And actually, probably my concern, may want to climb up this beautiful mountain dome. Anyway, just south of this city, we have totally different story, which is characterized by the lower hills shown here, including Mount Cheonggae, which is 618 meters. Compared to Everest, it is just kind of small hill. But in Korea, we call it mountain, Bukhan Mountain, very famous, and Cheonggae Mountain is another one. Anyway, this one is labeled by landmark tower, so-called Lotte World Tower, which is 555 meters. And here is the Han River running through the Seoul city. So south of the Han River, we call it Gangnam. Gang means river, Nam is south. So Gangnam Style is south of this Han River. Okay, I will talk mainly about the history involved in this Mount Cheonggae area. First of all, I'd like to briefly introduce Korean tectonics. It's quite complicated, but it is well known since the work of Amin, late professor at UCLA, and he has produced a beautiful model in that tectonics between the North and South China craters during the Permo-Triassic continental collision time. Anyway, Korea is situated at the eastern margin of Asia, and here is Nepal at the center of this Himalayan origin. But Korea is still debatable in terms of tectonic origin. Somebody says north, somebody strongly argues for South China crater activity. Anyway, recently, Park et al. Here has reviewed all the available tectonic models involved in Korean tectonics, and here is my model, and his own model suggests the Gyeonggi Massif at the center of the Korean Peninsula is a part of rapid reaction nation of the Chilling Belt from west to Dabi Sulu Belt, then Korean Peninsula towards the eastern part to Hida Belt in Japanese islands. Hida and Hida Marginal Belt might be very similar to Gyeonggi Massif and Gyeonggi Marginal Belt. So I have stolen the terminology from Japanese literature. Anyway, the Gyeonggi Marginal Belt is composed of 3 sub belts, which is kind of probably 15 or 20 years ago. We didn't have this kind of complexity at all. The complexity came from the introduction of shrimp machine inside Korea. We have installed shrimp machine in 2008. Then everything became very complicated because lots of data are coming out from the machine. So I think in the part you may have same story waiting for you. So if you introduce precise HDD, then you may have very complex story waiting for you. Anyway, they need your challenge. Here is the summary diagram showing all the photographs showing a variety of features. Here is an example of a weekly before cordial time, very nice. And here is the interlayer of metaphyllite and metasamite. You can see all the garnet photographs surrounded by quartz or biotite. And crystals beautifully preserved, but surrounded by cordial and silicate. Here you can see some of kyanite grains occurring as really grains, and they are surrounded by plateau plates, the formation of microstructures. Here is the outdoor photograph recently found during my hiking to this mountain with my friends, weekend trip. I was very surprised, because I found this kind of stretching of leucosomes or feldspar leucosome or rats. So they have different rheological behavior. And here you can note that the surely product of dynamic recrystallization. But here you can see billion years ago, a very long time ago. But certainly there is a signature of lead loss or dysphoria suggesting another thermal event during the Triassic time, right, 230 million years ago. But Geological is very robust, so it doesn't change much. But monazite, in comparison, is weaker than Geological, so it clockwise PT time loop. Here, one green shown here in green. As previous speaker has mentioned, we can be very careful by sorting out all the kind of compositions from core to the mountain Cheonggae. It's about 600 meters, so you can climb up very easily because you are trained enough. So when you visit Seoul, just try, and you can find at the top of the mountain, which is around 590 meters, we call it backbone. Here you can see typical migmatites. That is the product of Triassic granites, kind of leucogranite surrounded by this kind of traditional algae. We call it hano. Anyway, you can enjoy. Thank you very much.
I have one query. In one of all your slides, I have seen the fibrous variety of sillimanite,
Yes.
and then prismatic also, sillimanite and kyanite is there.
Yes.
So, as per your loop, the kyanite form first and then sillimanite
Sure.
and then fibrous.
Yes.
What do you think how the fibrous sillimanite is formed? What was the reason?
Well, it is my capability to answer, but it is well known. Fibrite is the product of rapid metamorphic process. So you can expect fibrite occurring at the onset of some metamorphic event. But here we certainly have two different
Episodes.
events. Yes. So the second one is very strong one, supposed to be very strong one, but it could be very short-term event. So there transformation.
There must be 3 episodes of metamorphism. What do you think? Three episodes of metamorphism, M1, M2 and M3?
Oh, well, this is kind of a simplified model, of course. But if you go into details, you can say it that way. Yes.
Okay, thank you very much.
Yep.
Next one is Sujan Raj Panze about field relation, fabric, and the cooling history of fibronite, Lesser Himalaya, granitoids, Central Nepal.
I recently graduated from Central Department of Geology, University, and today I had a chance in this National Geological Nepal Geological Congress. So my topic is field relation, fabric and cooling history of Ipa granite, Lesser Himalaya granitoids, Central Nepal. And I've worked with my colleague Pradeep Dekoda and my advisor Mary Gabad, Dr. Professor Lali Prasad Kaudat, and Dr. Paul Sullivan for one of the analysis. So in the Nepal Himalaya, granulates of Paleoproterozoic to Cenozoic age source distribution across different tectonic stratigraphic units from north to south. So you can see here on the red the Miocene lithogranites on the northern part, which are distributed within the Tethys Himalayan sequence and the higher Himalayan crystallines, along with the next is the Proterozoic gneisses and granites distributed within the midland groups of the Lesser Himalaya, and the Camera Ordovician granites and gneisses which are distributed within the southern flanks near the Siwa Lake zones, mostly within the Lesser Himalayan crystallines, and it sort of forms a belt on the southern flanks, forming ridges of the Mahabharat ridges. Next, and my interest here is on the Camera Ordovician granites, and particularly within these sections in the Kathmandu complex area, that is the IPA granite. Although the Stockling has mapped this area, and the Lesser Himalayan granitic belt has been named by Lefort in the et al. In the 1980s, and later on Lefort and Rai in 1999 in central Nepal Himalaya. It has 6 irregular granular bodies of varying dimensions that enters the rocks of lymphatic groups Kathmandu complex from west, and the field relation of granites within the country rocks, and for that I used the techniques of geological mapping, cross sections, and the geological sketches in the field. And other was to delineate the fabric in the granite. For that I used petrographic studies that includes the modern analysis using the manual point counting, followed by the fabric analysis that uses the grain size, textures, and structures. And also that some of the samples were sent to the Idaho, USA, to establish a cooling history of IPA granite through the apatite fission tracking in lab in geoset surveys. So this is the geological map here of Kulikhani Formation and Marco Formation. The Kulikhani Formation is the black schist, usually the black schist in the quartzite, shown by the pink color here, and the Marco is the marble, which usually with some phyllite intercalations. So this is the generalized columnar section, and it is identical to the that of the given by the Stockling. And these are some of the cross sections along this section, this one, and another one is on this flank on the east. So one of the objectives was the field relation of the IPA granite. So with the contact with the Kulikhani Formation quartzite, as I mentioned, there is 2 rock type mainly in the Kulikhani Formation, the black quartzite and mostly the black schist. So I made this case in the field and later digitized using the software. And this is this portion here that intrudes gradationally, and you can see that gradationally injected veins contact that transition from undisturbed quartzite at the south to zone of dikes and veins from main granitoids like this, and it has also the multi-phase intrusion, but that these both bodies both start at gradational contact, and with the mafic mafic sills in the schist and quartzite near the contact of granite and schist, it's shown in the A. Followed by this is the sharp contact between the granite and schist, also observed in the Kantipat highway, and another is the baked type of schist that's usually due to the ductile fashion resulting in the organ texture within this contact zones here. And also there are some of the tourmaline bearing pegmatite comparatively occurring as sills within the host rocks 50 to 200 meters away from the contact. And this pegmatite veins shows the graphic texture which resembles the late phase. It also has 50 to 100 meter contact areoles formed by the baked zones due to the contact metamorphism with development of on-field appearance like shown in the figure B. And also the other is the several para-empty sills within the granites, and these are of these black schist, and it is an inclusion of dark grey whales foliated schematic schist form the inclusion within the granite indicating pre-deformation withstand the intrusions. Sizes ranges from a few mm to several centimeters. These are my sampling locations I have seen, and I have divided the IPA granite, this lenticular body, into 4 sections, and the sampling was done within these 4 sections. One in the west, this is the Shinigari section, although only the single sample has been observed from this area, and followed by the Cisneri covered system, this and this bit here, and another is the Bagmati section around here, and another one is the Kantipat section around this part at here. The petrographic analysis with manual point counting was done, and next was we got the most of these is dominated by the quartz, followed by the alkali feldspar and plagioclase, showing this the proportion of the quartz and the alkali feldspar is dominated over the plagioclase, giving it the silicic composition of it. And the other minerals also were found, that is accessory mineral like apatite, zircons, epitone and quarterite. And along the three sections, we found that the bimodal distribution of grain size of quartz and feldspar, giving us an inequigranular relationship between the grains. And fine to medium grain minerals at the rim sections mostly, and at the coarser and larger phenocrysts of feldspar at the central part of the body, granitoid body. And this first one is the porphyritic granite with large alkali feldspar porphyry with inclusions showing poikilotic textures also with this kind of inclusions within the porphyry. And another is the flame perthite. Well, it is not although good one still. So another is the Tata training in showing the microclimes. On the marginal part, most of the granite shows the anisotropic fabric mostly, and with the deformation fabric being imminent. So this is the anisotropic weakly foliated granitic gneiss, and this is some of the organ gneiss textures developed within the plagioclase with rotating top to the south shear shears. And another is on the sea, we can see is the elongated biotite grains in enclave cells on genoliths during granite. Isotropic includes the porphyritic granite and coarse grained equigranular granites, most A and B. Geosep services in Idaho lab, and he modeled these three samples. And what we can see here is that all the samples are 65% with mineral assemblies of quartz, alkali feldspar, plagioclase, biotite, muscovite, tourmaline, and quarterite, and are predominantly inequigranular porphyritic textures with fabric gradationally varying from finer medium grain granite gneiss at margin to porphyritic, and this relative tradition age of the Ipa granite coincide with the ages from the reactivation of the Mahabharata thrust and the activation of the MBT in the central Nepal with Johnson et al. 2001, which may have suggested in deformation within the Ipa granite. Similarly, these findings with the efficient track dating of three samples from following and Ipa granites also.
So thank you very much. We will take from you.
You have shown in your rock the chordite is there along with garnet.
There's no garnet.
No garnet.
No garnet.
Then okay. It's okay if no garnet is there.
Yeah.
Otherwise, it will be very tough to explain how
there were no garnets.
no
Only
garnet.
biotite.
Only biotite and
Yeah.
chordite.
Yeah, quarterite. I distinguish it with the optical properties.
So,
It was
how
hard.
many phases of metamorphism you suggest?
Likely more than one, but I don't know exactly how many phases of deformation, but likely it would be around
Because
three.
last phase is your thermal metamorphism.
Oh yeah.
Before that must be one regional metamorphism.
Yeah, the cyst, the enclaves and genoliths, there was already the metamorphisms before the intrusions of the.
You have checked that in closed genoliths, is there any garment which is
No, I didn't find any garnets within there, only biotites there.
okay, thank you.
Thank you very much.
Mr. Nepal Sarmani.
Good afternoon, everyone. Today I am going to present about the petrographic depositional setting and provenance of the Gondwana sequence in Eastern Nepal Himalaya. And I have done this work as my master's thesis along with other researchers. To give you a short introduction about the Gondwana, these Gondwana rocks represent the late Paleozoic to early Cenozoic rocks deposited within the crateric interior of different landmass. And the Gondwana rocks are mostly present in two types of basin. One is in the crateric Indian peninsula, which is called peninsular Gondwana, and one in the foothills of the Himalaya, in the frontal part of the lesser Himalaya, which are called the extrapeninsular Gondwana deposit. And the peninsular Gondwana are more or less continuous and undisturbed sediment, but extrapeninsular Gondwana occurs in discontinuous patches and highly sheared and folded.
This is the study area lies in the eastern Nepal Himalaya, and the study area lies just north of the main boundary rocks. And talking about the importance of this study, in the eastern Nepal Himalaya, focusing on the Gondwana rocks, there are very few petrographic studies. Only 2 to 3 samples, chosen samples were studied, and obviously the interpretation of depositional environment and provenance of this sedimentary sequence of Gondwana rocks were not done before. So I tried to conduct this study, and mostly the way throughout the Barak Kshetra area. And our study is mainly focused, and we traverse mainly along 3 sections, which is the westernmost part, Rakse Khola section, and the central part, Saptakoshi River section, and the eastern part, Poka Khola and the Latare Khola section, columnar section of the Gondwana rocks in the Barak Kshetra area. Now I want to go to the petrography of the rocks I did. I want to start from the lowermost unit, which is the Coca diamictite, and the Coca diamictite consists at its base is the conglomerate, and I have prepared thin sections of conglomerate, and as you can see there are very larger grains of quartzite in matrix, also in silicic composition, and the grains are mostly looks like recrystallized and boundaries are indented. This is possibly due to there are numerous intraformational thrust within the Gondwana sequence, which resulted in this type of the texture, and the total composition is as I mentioned here. And these are the 3 types of sandstones found in the Coca diamictite, which is the oldest unit of the Gondwana. And as we can see, there is a variation in the grain size and the texture. The lowermost sandstone is partly recrystallized, just like the conglomerate, but the other 2 sandstones are immature, and so the grains are floating in matrix, and the cements are mostly calcite, and we can see feldspar of plagioclase and both alkali and plagioclase feldspar, and as well as diamictite taken from 2 different sections. As we can see, this is very poorly sorted grains, and grain size as large as this one rock fragment, and this is the sample of the diamictite, and the rocks are mostly angular, they are not reworked much, and the feldspar, as we can see here, feldspar are mostly preserved, and they are very less altered, which is typical for the glacial or in cold environment. And talking about the next Tamang formation, which follows the Coca diamictite, I slightly increases, and the feldspar content is very high in the lowermost section, and it's completely absent in the uppermost section, but are present in these rocks also, and rock fragments like metamorphic, the diamictite, conglomerate, and sandstone of the Coca diamictite, and the sandstone of the Tamang formation and major constituents. And these are the samples in the very few quartzite, mostly cemented by calcite and other minerals, but the majority of the matured as compared to the other rocks. And this one is the carbonaceous sandstone, and all the black minerals are carbonaceous minerals, and the grain boundaries are not clear, and they looks like they are blended into the matrix, but this more or less represents. I recalculated the major constituents of quartz, feldspar, and lithics for the classification of the sandstone. And for the classification, I use Falk 1980 triangular diagram, which use 3 members: quartz, feldspar, and lithics. And most of the samples fall into the sub-arkose, sub-lithiarenite, and quartz-erinite, and 1 sample fall within the feldspathic lithiarenite. I am going to talk about that. I put some of the primary features that I observed in the field. This is the conglomerate, and this is the diamictite of the Coca diamictite, both of which are very poorly sorted and are massive. These 4 photos are from the Tamang formation, which here because most likely all of the authors, previous authors, thought that the Baraha volcanics, which lies within the Tamang formation, is contemporaneous with the sedimentation of the Tamang formation. Both occur in the same time, but from this field study and as well sediments of the Kathmandu Nepal. And talking about the depositional modes, The sedimentary sequence and the thin section petrographic analysis showed that the Coca diamictite bearing unit was mostly deposited in the glacial cold environment, in glacial, glaciofluvial and glaciolacustrine environment. And this Coca diamictite represents the late Carboniferous to Permian, late Paleozoic to early Mesozoic rock. During that time, these sediments, along with in the Barakshetra area, as well as in other part of the peninsular India, were deposited in a similar setting in intracratonic graben developed along the paleosutures of the Pangaea. At that time, there was Pangaea. And conglomerate at the lowest part indicates deposition by debris flow, and during that time the glacial environment and the braided river shifted into the meandering river system, which deposited the Tamang formation. And sandstone shows climbing upward sequence, cross lamination, climbing ripples, and its migration towards the Tibetan plate. And Saptakoshi formation was deposited in the northern shelf of the India when it broke with Australia and Antarctica, and the sediments were sourced by the north flowing rivers of the Indian Craton, and the sediments were brought from all over the Indian Craton from various rock sources. Similarly, I plotted the petrographic data into the provenance classification following the Dickinson et al. These are the two provenance diagrams using monocrystalline quartz, feldspar, and lithics. Like the Binyan groups of rocks, Sosnagar Gneissic complex, and Malani granite and related rocks in the northern India, because in the thin section also we can observe most of the granite and the gneiss and schist, then the Coca diamictite. Only the environment changed from the cold glacial to relatively warm and semi-humid condition. So the source for the Tamang formation is similar to that of the Coca diamictite, only the environment of deposition changed during that time. And talking of the Saptakoshi formation, it was deposited in the northernmost part of the Indian Craton. So the sediments were mostly sourced from the Craton interior, which is also seen on the east maturity of the sandstone, as we observe the quartz erigite in the Saptakoshi formation, as well as the coal occurrence within the Saptakoshi formation is likely.
Next speaker will be Arjun Batarai, speaking about the petrogenesis of the granites from the Kathmandu area of central Nepal.
Thank you so much, and namaste and good afternoon everybody. Today I am going to present from the Central Department of Geology, TU Tribhuvan University, Kathmandu, Nepal, and major outlines. Basically, stages of the granite evolution: contour rock formation and metamorphism in Precambrian stage, intrusion stage in Paleozoic, Himalayan uplift stage at Tertiary, and Himalayan monsoon erosional stage at Quaternary. And these are the main tasks of this study. And the study area lies in the lesser Himalaya, central Nepal. There are three conspicuous belts of granite occur in the Himalayas, which from north to south are the northern Himalaya granite, the greater Himalaya granite, and the lesser Himalayan granite belt in Nepal area. My study area lies in the lesser Himalaya. The metamorphic rocks have been intruded by the granite bodies, which belongs to granite belt of the lesser Himalaya, and in that we can see the study area. And this is the regional geological map of the study area published by DNG 2020. And the study area lies here. This granite, there are continuous three granite belt we can see here. This is the Agra granite in western part. This is the Balun granite in mid part, and in this part, this is small body is the Ipa granite. This is continuous, and this is the Sinduli Naranthani granite. Continuous, these are the granite belts in this lesser Himalaya. And there is one marble thrust in this part, study area. In this part, this is western part is the gneissic granite, and this is in the mid part of the granite body, except in the few places. This granite is white to grayish in color, medium to coarse grain, containing quartz, feldspar, biotite, muscovite, and tourmaline. The granite in the area is medium to coarse grain, which reflects slow cooling and the presence of the volatiles, which facilitates the mineral growth. Large alkali feldspar megacrysts are common in this granite body. alkali feldspar, quartz, and the plesioclase are the major dominant minerals. And muscovite granite lies on its boundary zone, whereas biotite granite lies on the central part of the granite body, mostly in this mid part of the granite. But there is the biotite granite. The pegmatite lies at the central part of the granite body. In this part, in the central part, there is the pegmatite. In other part, this western part is covered with the gneissic granite. And we can see in this image also, there is the leucogranite and this biotite granite in this part. This is the muscovite dominant granite and this is the pegmatite granite. And the western part is covered by this gneissic granite. The western part, Kaltar-Khairang area of the study area is covered with the subtype of gneissic granite. The gneissic granite is indicated by the thorium lead edges of the monazite inclusion in the garnet crystals. And in uplifted stage, this was the deformed of the granite, and the granite slices and seals and dikes are folded, showing late stage metamorphism related to Himalayan uplifted stage. Gneiss in the west part and few myelonitic gneiss. This is the myelonitic layer, shear zone also observed in the granite body. And lower one is the gneissic granite of western part. This is the seals and folded seals. Means it represents the deformation after the intrusion. And the secondary melting and recrystallization also can be seen here. This is it might be in the tertiary age Himalayan uplifted stage. I have not calculated the age of this time, but the previous researchers also calculated the stage of metamorphism, date of metamorphism. That's why also I can say that this is the secondary melting and crystallization. And grain size variation also we can see here, slightly deformed granite showing the mica and feldspar layers, and different layers we can see here, coarse grain feldspar, and the deformation we can observe and recrystallize we can observe here. This is the developed. We can see here the foliation developed in the granite. We can see. It means it is the late deformed. This rock has been deformed in the late stage. We can see from this foliation in different parts. We can measure this first type of foliation in the granite. This is the highly deformed, highly weathered granite, caolinitized in the east of the Palung area. Its thickness is about 10 meter in most of the area, and it was noticed up to the 15 meter in some parts. And this is the caolinitized feldspar rich granite. And the caolinization might be the started after monsoon. This caolinization is in the feldspar granite. The thick caolinite layer is up to the 15 meter in the Palung area. And this first type of caolinization is observed in the southwest part of the granite body, gneissic body, and the northeast of the granite body, where the feldspar is dominant, and in the mica granite. Deformed feldspar we can see here, and the recrystallized sericite and the muscovite crystal within the feldspar we can see here. And this might be, the deformation might be after the monsoon. And this is the comparison of the lesser Himalayan granite in the other parts of this Himalayan orogeny. There is the Palung granite lies here, Palung granite, and age is almost similar in these granites. In this western part there is the gneissic granite in this western part, and in this mid part less deformed granite with gneissic granite is here in this part, and the chemical composition is almost similar in study with the other research papers. The chemical composition is almost same, and so we can say that the origin of this granite is similar with the other granites. And this is the photo of the Ipa granite, just similar of that granite, lying in the east of that granite body. Graphic granite suggests high volatile in pegmatite, and deformation texture indicates into post-orogenic emplacement, and high aluminous and the muscovite granite belongs to the S-type granite. Orientation of the platy minerals indicates the secondary deformation, and presence of such muscovite bearing granite are associated with the collisional tectonic setting by the crustal thickening and melting. Feldspar and biotite color into the muscovite due to the fluid inclusion during the retrograde metamorphism.
Well, we have just time for a short question. So let's proceed and go straight to next speaker.
Okay, thank you.
So next speaker will be Alina Karki. Then she will focus her talk on the geological characteristics of Ulleri Uluriness.
I'm Elina Kalki. I'm from Nepal Electricity Authority and working as a geologist as well as a PhD scholar from Central Department of Geology. The topic of my presentation is geological characteristic of Ulleri organized in the Birethati Gorepani area of Western Nepal. So in the introduction part, my present study area lies on four Himalaya physiographic distribution and comprised of midland group of rock of recent Himalayan sequence, and it was studied to map its geological distribution, field relation with adjacent rocks and petrographic characteristics. And the main lithology of the study area was phyllite, meta sandstone, schist quartzite with the occurrence of metabasic and organized. The Ulleri organized is distributed within the Kuncha formation of the lower Nagar complex group Lesser Himalaya, and the location map of the study area is right there. So the main objective of the study area is to clarify the geological setting of the gneiss granitic rock in the Ulleri Gorepani area and to carry out the microstructure characteristic of the granitoid. And these were the methodology I carried out during my study. First, next study, then review of available literature, geological map, satellite map, and there was a route planning, and then field work and other survey were carried out. And in the lab work, I carried out this section preparation from the CDG, and petrography and structure analysis was done, and that and in the process of manuscript writing. So this is the geological map I have prepared of the study area and inside columnar section. So in the lithostratigraphy section, my study area covers Kuncha formation and Spagfog quartzite, and organized is another major lithological unit exposed within the Kuncha formation succession. And Kuncha formation part, it comprises of various rock units which include quartzite, schist, gneiss, metabasic phyllite, and meta sandstone. And in the section of Spagfog quartzite, it consists of medium to thick bedded milky white quartzite with grey colored phyllite. Part is organized to the country rock. In my study area, there are two types, like one is concordant and another is discordant relationship between schist and gneiss. Concordant relation was observed on the way to the Naglithati from the Ulleri, and discordant relationship was observed on the way to the Lespart from the Gurunga village. Next slide. And genolith was also observed, and we have prepared some thin sections of that. So, and these are the deformational structure we observed in the study area. This is the rod structure observed in the organized, and port pyroblast showing top to south sharing in the exposure of the gneiss from and depositional structure observed in my study area with the image. This is the ripple mass which was found in Spagfog quartzite, and another cross lamination observed this in the Spagfog quartzite. And the metamorphism part shows increase in the grade northward, that is stratigraphically upward, and biotite which appear in the rock unit of lower section expected more majority towards the northward section. The elongation of the quartz grain from rounded grains in the metamorphic rock often indicate the increase in the grade of metamorphism. The green phyllite which appears in lower unit of study area is metamorphosed to mica schist with prepared like the layering and intersecting of planar fabric of schist under PPL. So and others are also of the gneiss, including in the thin section. Next. And these two are also the thin section of gneiss, which shows the blastomitic texture indicating deformation and recrystallization. And this shows the garnet in this here. You see the garnet in this thin section in the core and biotar in the rim of this from the Kuncha formation. And the next thin section shows the mica mineral quartz veins, plagioclase feldspar and quartz mineral in the schist from the Kuncha formation. Next. So, and this photomicrograph shows the potash, feldspar, plagioclase, feldspar, quartz and biotite mineral in gneiss. Next, from William. And the conclusion part. My study area is predominantly lies within the Kuncha formation with characteristic grey-green light, grey to dark grey. Thank you for your attention.
Okay, thank you very much.
Thank you so much.
There is no discussion now on the posters. We did this. We did this already. One. Is there one? Who is the one? But we had that already, didn't we?
Yes, thank you very much. So, thank you very much. So I'd like to call Convener Professor Dr. Kumar Gordon to present a token of appreciation for our chairperson, co-chairperson and rapporteur. So I'd like to call the chairperson for this session, Professor Dr. Lauren Bollinger, to receive the token of appreciation.